Are you looking for an adventurous summer job? Well, how about hunting invasive Burmese pythons in the Everglades?
Biologists at the Conservancy of Southwest Florida believe one of their scout Burmese pythons.
The last signal came in at 4:52 in the morning. Then nothing. For 3 years, a research team working the southern rim of the Everglades had followed one particular Burmese python through a small transmitter stitched under the skin near its tail. The snake was just over 12 feet long, thick through the middle, and had survived 2 flood seasons, 1 drought, and at least 1 close call with an airboat propeller. In the internal logs, the biologists called him Unit 47. Somewhere along the way, the tech running the tracking software started calling him the Ghost, because he had a habit of vanishing into cypress domes for weeks and reappearing exactly where the models predicted he shouldn't. The morning the signal went quiet, nobody on the team assumed the worst. Transmitters fail. Batteries die. Snakes bury themselves in mud during cold snaps, and the GPS simply can't punch a fix through the water table. So the field technician assigned to check on him drove out with a thermos of coffee and a mild sense of annoyance at having her Saturday interrupted. What she found 2 hours later was not a dead battery. The python was there, mostly. Its body was intact, coiled loosely in the grass the way a resting snake settles when nothing is chasing it. But the head was gone. Not mangled, not chewed, gone. Removed at a point just behind the skull with a precision that looked almost surgical. There was no blood trail leading away, no drag marks through the sawgrass, no sign of a struggle. Whatever had done this had approached, struck once, then left. The pine litter around the body had been disturbed in a strange, deliberate pattern, as though something had tried to scatter debris over the kill site before abandoning the effort. The technician did what field researchers are trained to do. She photographed everything, bagged what she could, and called it in. Nobody at the station had an immediate explanation. Alligators don't decapitate prey with that kind of clean precision. They roll, they twist, they tear. A human trapper would have taken the whole snake, not left an expensive research asset rotting in the grass. And whatever had done this had done it to an adult python nearly as long as a compact car, an animal that, according to 2 decades of published research, was not supposed to have any natural predator capable of killing it in the Everglades. That single mystery kill turned into one of the most quietly significant discoveries in the 20-year saga of Florida's python invasion. Because once researchers went looking for similar wounds, they didn't find one incident. They found a pattern. For most of the last 2 decades, the working assumption inside Florida wildlife agencies was straightforward and grim. Adult Burmese pythons in the Everglades had, for all practical purposes, no natural enemies. They arrive in the swamp already fully grown from the exotic pet trade, or born there with no evolutionary history connecting them to the local food web. Native predators had never seen anything like them, and had no instinctive playbook for dealing with an animal that can weigh more than a grown man and strike with enough force to break bone. That assumption shaped how conservation money got spent for years. Removal programs focused almost entirely on human hunters, detection dogs, and camera traps, because the prevailing wisdom held that nature itself wasn't going to solve this problem. The snakes had already proven that point in devastating fashion. Surveys conducted across the southern Everglades in the years following the python boom found that populations of raccoons, possums, and rabbits had collapsed by well over 90% in some study areas. Bobcat sightings themselves had grown sparse enough that some researchers quietly worried the cats were being squeezed out entirely, losing the small mammal prey base they depended on to the very snakes that were now apparently dying to them. Except the cats weren't disappearing. They were adapting. When wildlife biologists in Big Cypress and the surrounding preserve lands started reviewing months of trail camera footage with fresh eyes, specifically looking for headless or decapitated python carcasses, they began finding the signature again and again. Different locations, different individual snakes, some radio tagged, some not. The same wound pattern, a clean strike to the base of the skull, minimal struggle, and in several cases, a deliberate attempt to cover the remains with leaf litter or loose soil afterward. The animal behind it, once cameras finally caught the act in progress, turned out to be almost comically undersized for the job. Bobcat, an animal that typically tops out around 25 to 30 pounds, going up against snakes that can outweigh it by a factor of 5 or 6. To understand why this works at all, you have to understand what a bobcat is actually built to do and what a python is not built to defend against. Bobcats are ambush specialists. Their entire hunting strategy is built around patience, concealment, and a single explosive strike delivered at exactly the right moment. In their traditional range, that strategy is aimed at rabbits, rodents, birds, and the occasional fawn, fast, twitchy prey that requires precision timing rather than raw power. What nobody expected was that this same skill set could be redirected at an animal roughly the length of a canoe. A Burmese python's primary weapon is constriction. Coil around prey, tighten with every exhale the victim takes, and eventually stop the heart through sustained pressure. It is a devastatingly effective system against almost anything that gets caught in its grip. But it depends entirely on the snake having time to react, to sense a threat, coil defensively, and bring that crushing strength to bear. Take away that window, and the python's greatest weapon becomes irrelevant. The vulnerable point is the base of the skull, where the spinal cord passes through a comparatively narrow, poorly armored section of the neck. Sever the cord there, and the signal pathway between brain and body is cut instantly. The muscular coordination required to coil, strike, or even flee collapses in a fraction of a second. It's the same principle that makes a well-placed strike behind the head lethal against almost any snake species, only here it's being executed by a wildcat against prey many times its own body weight. Camera footage recovered from several of these encounters shows a consistent hunting sequence. The bobcat locates a python that is stretched out and exposed, typically basking or moving slowly through open ground rather than coiled defensively in cover. It approaches with almost absurd patience, sometimes circling for the better part of an hour, staying low, using available vegetation to break its outline, and crucially, never triggering the vibration-sensitive receptors along the python's belly that would normally give the snake advance warning of an approaching threat. Then, in a movement fast enough that some camera footage barely resolves it cleanly, the cat drives its full weight down onto the back of the snake's neck and delivers a bite aimed squarely at the cervical spine. It's over in seconds. There is no prolonged fight because if there were, the python would very likely win. This is not blind instinct. Instinct, in any straightforward sense, should be telling a bobcat to avoid an animal that size entirely. What the footage actually shows is closer to learned, calculated risk assessment, a hunting strategy assembled and refined against a threat that didn't exist in this ecosystem a generation ago. If the individual kills were surprising, what researchers found next was arguably more significant for the long-term math of the invasion. At a separate site, a trail camera captured a bobcat locating an active python nest, a clutch of eggs guarded, as Burmese pythons often do, by the female coiled protectively around them. Rather than attempting a direct confrontation with an adult snake in full defensive posture, the cat waited. Python mothers occasionally leave a nest briefly, particularly during warmer stretches when the eggs don't require constant thermoregulation from the parent's body. During one such window, the cat moved in and began systematically working through the clutch, egg by egg, rather than simply hauling one or two away. What made the behavior stand out to researchers wasn't just the meal, it was the follow-through. After finishing, the animal spent time disturbing and partially covering the nest site, the same rough concealment behavior noted at adult kill sites elsewhere. Biologists studying the footage suggested this wasn't accidental. A single clutch from an adult female Burmese python can run anywhere from 50 to well over 100 eggs. Eliminating a nest entirely removes a far larger future threat than a single kill ever could, and the deliberate disturbance of the site may reduce the odds of the location being reused. This kind of behavior, targeting reproduction directly rather than only adult individuals, had not been documented in bobcats before this invasion. It raises an uncomfortable but fascinating possibility that a population under severe novel pressure from an invasive predator can develop entirely new hunting strategies within the span of a few cat generations, far faster than traditional evolutionary timelines would suggest is possible. What's likely happening is less classic genetic evolution and more rapid behavioral learning, young cats observing and copying successful adults. Effective techniques spreading through a population the way any learned skill spreads among social or semi-social animals watching one another survive. Bobcats did not arrive at this fight alone, even if they've turned out to be its most surprising participant. Alligators occupy a strange middle position in the python conflict. In the earliest years of the invasion, there are documented cases of large pythons killing and consuming juvenile alligators, a genuinely alarming development given the alligator's status as the Everglades' longtime apex predator. But that relationship has clearly shifted as pythons have become an established, abundant prey source in their own right. Trail camera and eyewitness accounts from multiple sites now show large adult alligators, animals in the 10 to 11-foot range, actively seizing pythons and using the same rolling technique alligators use to subdue any oversized prey, twisting until the snake's spine gives out. Where a juvenile gator might once have been vulnerable to a python, a mature alligator appears to have flipped the relationship entirely, treating pythons as both competitor and convenient meal. Wading birds have joined the effort at the other end of the python's life cycle. Great blue herons and red-shouldered hawks have both been documented taking hatchling pythons near nesting and emergent sites. A heron's bill, driven downward with the bird's full body weight behind it, is more than capable of killing a newly hatched snake instantly. This matters disproportionately because the hatchling stage is the one point in a python's life when it is genuinely vulnerable to a wide range of predators. Every hatchling taken by a bird is one less animal that will eventually grow past the reach of anything in the swamp except an alligator, a bobcat with exceptional timing, or a human hunter with a flashlight and a truck. None of this adds up to the ecosystem solving the python problem. Wildlife biologists are careful to stress that point. Even generous estimates of bobcat-driven mortality wouldn't meaningfully dent a python population that some surveys have placed anywhere between the tens of thousands and several hundred thousand individuals. A number so uncertain it says more about how well these snakes hide than about how many actually exist. But the discovery does something else that matters just as much. It shows that the Everglades is not a passive victim absorbing damage indefinitely. Parts of it are pushing back, adapting, and in the case of the bobcats, doing so with a speed that has genuinely surprised the people who study this ecosystem for a living. None of this new predator activity erases the scale of the problem, and it's worth being honest about just how large that problem still is. Burmese pythons entered Florida through the exotic pet trade beginning in the 1970s and 1980s, with escapes and deliberate releases slowly seeding a wild population in the Everglades. Hurricane Andrew's destruction of a reptile breeding facility in 1992 is widely believed to have accelerated the process dramatically, releasing a large number of animals into the wild in a single event. From there, the population grew largely unchecked for years before wildlife agencies fully grasped the scale of what was happening. The consequences for native wildlife have been documented extensively. Surveys tracking mammal populations along Everglades roadways found declines exceeding 90% for several species compared to pre-invasion baselines, with some animals functionally disappearing from large survey areas entirely. Beyond the visible loss of wildlife, researchers have also raised concerns about the Everglades' broader ecological role. The region serves as a critical water source and natural filtration system for millions of South Florida residents, and the loss of small and mid-sized mammals disrupts plant communities and hydrology in ways that ripple far beyond the immediate question of which animals are or aren't visible from an airboat. Human removal efforts have made real, measurable progress, but they operate against a fundamentally difficult adversary. Pythons are cryptic by nature, exceptionally well camouflaged, and capable of remaining motionless and undetected for long stretches, even when a trained hunter walks within a few feet of them. Professional and volunteer hunters working organized removal programs have collectively taken tens of thousands of pythons out of South Florida over the life of these programs, and the data collected from every captured animal, size, weight, location, reproductive status, feeds directly into the population models researchers rely on. It's genuinely important work. It has also never been enough on its own to reverse the trajectory of the invasion, simply because the snakes reproduce and disperse faster than any team of humans can physically search a landscape as vast and dense as the Everglades. That gap is exactly why the bobcat discovery matters as much as it does. It's not a replacement for human intervention. It's evidence that the ecosystem may be assembling its own partial response alongside it, one that costs nothing, requires no funding, and appears to be spreading through the local wildlife population faster than anyone expected. There's a harder piece of this story that tends to get less attention than the python versus bobcat footage, and it concerns what these snakes are becoming rather than what's hunting them. Genetic research over the past several years has confirmed that Florida's Burmese python population includes individuals carrying DNA from a closely related species, the Indian python, introduced through the same exotic pet trade pathway decades ago. That hybridization matters because Indian pythons come from regions with meaningfully colder winters and correspondingly better cold tolerance than pure Burmese pythons possess. Cold weather has functioned as one of the only natural barriers keeping this invasion geographically contained. A hard freeze reliably kills unhybridized Burmese pythons, which is a large part of why the population hasn't already pushed north into Georgia, Alabama, or beyond. Hybrid individuals carrying that improved cold tolerance represent a genuine unknown for how far this invasion could ultimately spread. If that trait becomes widespread within the population, The northern boundary that has protected the rest of the southeastern United States for the last 30 years could weaken considerably. States like Louisiana, with millions of acres of coastal wetland, or Alabama and South Carolina, with extensive river delta and marsh systems of their own, currently have none of the removal infrastructure, trained personnel, or public awareness that Florida built over 2 decades of hard-won experience. If hybrid pythons with expanded cold tolerance were to establish breeding populations further north, those states would essentially be starting from zero against a threat Florida is still struggling to fully contain even now. Wildlife agencies have responded by expanding environmental DNA monitoring, a technique that detects trace genetic material shed by animals moving through water, allowing researchers to confirm a python's presence in an area even when the snake itself is never physically spotted. Monitoring stations using this method have expanded into northern Florida in recent years, specifically to catch early signs of range expansion before it becomes an established breeding population rather than an isolated escaped pet. There's an added complication on top of the biological one. Researchers have also observed pythons in heavily hunted areas becoming noticeably more cautious around human scent and activity over time, a shift some attribute to selection pressure. Individuals that happen to avoid areas with heavy human traffic simply survive longer and reproduce more, gradually nudging the population toward more evasive behavior. It's not conscious learning in any meaningful sense, but the practical effect is the same. A species that is quietly getting harder to detect and remove at precisely the moment when early detection matters most. Step back from the individual kill sites and the trail camera footage, and what this story ultimately documents is something rarer than a single clever predator finding an unexpected meal. It's a live, real-time example of an ecosystem under existential pressure, generating a genuinely new survival strategy within a handful of animal generations, rather than over the centuries or millennia such adaptations typically require. The bobcats that figured out how to kill adult pythons safely are, almost certainly, descendants of the individuals who happened to survive the worst years of the invasion, the years when small mammal populations collapsed and an entire native predator faced the very real possibility of starving out of its own home range. The ones that adapted, that started watching python behavior closely enough to identify a killable window, passed that behavioral edge forward, and it appears to be spreading through the wider population faster than anyone studying this ecosystem initially believed as possible. None of it guarantees a happy ending. The mathematics of the invasion are still lopsided, the hybrid cold tolerance question is still unresolved, and human removal programs will remain essential for the foreseeable future, regardless of how many pythons the local wildlife manages to take down on its own. But the fact that a 25-pound wildcat has learned, on its own, how to bring down an animal 5 times its size and then deliberately conceal the evidence afterwards says something meaningful about how resilient a damaged ecosystem can be when it's given even a sliver of a chance to fight back. The Everglades has spent 30 years absorbing one of the worst invasive species disasters in North American history. For the first time in a long time, it's not entirely clear that the swamp is losing.